Okay, welcome to the NUPOC video study guide number 29. Let's look at question 3 in the graphing math section of guide 1. So we're going to take a look at this function here, y equals e to the minus x squared. And some of you may be thinking, well, this is a little bit ambiguous. Is this e to the minus x squared? Is it e to the minus x squared? Or maybe is it e to the minus x squared? Now, if you're following along with the solution manual, you'll see that this is interpreted as e to the minus x squared, which results in a decaying exponential from x equals 0 both towards x equals minus infinity and x equals plus infinity. So let's talk a little bit about why that's really the valid interpretation. That's really the intention when you write something like this. Okay, so let's first of all go ahead and graph that, and then let's look at the other two possible interpretations and see why they really don't make sense. Alright? So if we were to graph this function here as, let's graph it over here, right? Like this. Alright, so our x and y, okay, and let's pull this over here, and let's put in the parentheses to make it abundantly clear how we're interpreting this, right? And this, like I said, this is what they, how they interpret it in the solution, and this really is the correct interpretation. This is the valid way to look at this. Okay? So if we had x equals 0, of course this would be 0 squared, it would be e to the 0, so that would be 1. So let's say that's right here. Let's say that's y equals 1. Okay? And let's look at the other points of interest when x equals 1 and minus 1. So if x equals 1, right, this is just 1 squared and then minus, so it's e to the minus 1, so it's 1 over e. It's about 0.36, so maybe that's down about this level here. Okay? And now since we have an even power here, x is to an even power, it doesn't matter whether we have x or minus x, that negative sign is going to go away. So if we put negative 1 here, this is just going to be 1 in the parentheses, and we'll add a minus to it, and so it'll also be, our function will also be 1 over e at x equals minus 1, as well as x equals 1. And we're just going to decay, we're just going to continue an exponential decay from there. So it's going to be, let's say, our x equals minus 1 is here, and let's see, x equals 1 is here. And let's just kind of draw this across here. Right? So this is 1 over e, right? The y value here is 1 over e at x equals minus 1, and again at x equals 1. So we intersect this point, and we just decay towards negative infinity, and we decay towards positive infinity. Okay? And you'll see that's the same in the solution. Now let's look at, for example, if this was e to the minus x squared, right? So let's draw our plot right here, let's say. Right? Okay. So if we said this was y equals e to the minus x squared, you can already see sort of why this isn't really it doesn't make sense to interpret the problem this way. Because if we put the minus with the x, and then we square it, well, this minus is just going to go away, like we just talked about. So this is really the same thing, right, as saying e to the x squared, right? So why would you say e to the minus x squared? Why would you put the minus there, right? See, the minus is there so we can get this curve, right? If we wanted to be interpreted this way, right, we would just write e to the x squared. We wouldn't bother with the minus sign. See? But let's go ahead and draw what this would look like. So if it's just e to the x squared, again, it's going to start at y equals 1, okay? And when we get to 1, x equals 1, or x equals minus 1, we're going to be way up at e, right? So that's probably right about here, about y equals e, right? And we're just going to continue our exponential growth from there. So something like this, right? So very different graph, exponential growth in both directions instead of exponential decay. But again, this is just e to the x squared, so there's really no sense if you put the minus sign there. This is really the intended interpretation. If you wanted this graph, you would just write e to the x squared. Let's look at the final, last sort of possible interpretation and see how this one really isn't valid at all. You know, this interpretation, I can kind of see the confusion, and you kind of have to write it out to see why. Okay, it doesn't make sense to interpret it this way. Let's look at this last one. Let's look if you said y equals e to the minus x squared, right? So I could kind of see maybe someone saying, well, you know, you could do this. This is okay, right? But really, it's not. It's a completely different function, right? So this is really y equals e to the minus x, right? So this is really just e to the minus 2x, right? Which is a completely different function. At x equals 1, it's going to be 1 over e squared. At x equals minus 1, it's going to be e squared. So it's going to grow. It's going to have a completely different shape, basically. Let's look at, say, if this was x equals 1 here, or sorry, excuse me, y equals 1, right, at x equals 0. And let's say out here this is x equals 1, and this is x equals minus 1. You know, we're going to be way up here somewhere at e squared. I mean, the y-axis is going to be a little bit distorted here, but this is going to be the coordinate, right, minus 1 e squared, and this is going to be way down low. This is going to be somewhere down here, and this is going to be the coordinate 1 over e squared, right? So, right? So this is a completely different function, and if you wanted the function to be interpreted this way, you would just be writing y equals y equals e to the minus 2x. So this is how they interpret it in the solutions, and this really is the intended interpretation, right? If you have the minus sign there, it means that you're just taking the negative of whatever you're doing to x. You know, you're taking the negative of whatever here is in the exponential.